Forget everything you think you know about chemistry. The bubbling beakers, the white lab coats. Today, we are witnessing a revolution. The very lines between scientist, engineer, and AI are just blurring. We're talking about a fundamental rewrite of how we create new molecules. So let's dive into this new frontier. This quote from ScientistNews just says it all, doesn't it? That iconic, almost romantic image of the lone chemist toiling away in the lab, it's fading fast. It's basically becoming archaeology, replaced by a new reality that's powered by automation, data, and artificial intelligence. In this slide, this gets right to the heart of that transformation. We're shifting away from the idea of an artisanal chemist, someone whose value was all in their steady hands and their ability to memorize countless reactions. Now we're seeing the rise of the hybrid chemist, someone who partners with intelligent machines to do what was once, frankly, impossible. Okay, so how is this new reality actually being built? Let's break it down. We're going to look at the 4 technological pillars that are completely reshaping the entire field of chemistry as we know it. First up is what I like to call the AI dream chemist. And look, this is a massive, massive leap forward. This isn't just about predicting how a reaction might go anymore. Oh no. We are talking about AI that can literally dream up entirely new ways to create molecules, pushing the absolute boundaries of what we thought was possible. At the core of all this is a concept called retrosynthesis. Think of it like a chemical GPS. You tell it the big, complex molecule you want to build, and it works backward, charting the most efficient path to get there, starting from simple, easy-to-get materials. And this slide really highlights the huge difference in approach. See, old software was kind of like a librarian. It was limited to finding what was already known, what was already published in the vast library of science. But this new generative AI, it's a dreamer. It's capable of imagining and proposing brand new chemical pathways that no human has ever even tried before. And these AI planners are incredibly sophisticated. They don't just see molecules as flat drawings. They understand their complex 3D shapes. And they're not just about chemistry either. They're also really savvy economists. They can factor in the cost and availability of materials right from the very beginning of the design process. And this is where the power of these systems just blows my mind. Stereochemistry, that's getting the 3D arrangement of atoms just right, is a notoriously difficult challenge in synthesis. Well, these AIs can now solve it with an incredible 94% accuracy. That is an absolute game changer. Okay, so you have this brilliant AI-generated plan. Fantastic. But how do you actually bring it to life? Well, you give that digital brain a physical body. You create what people are now calling a self-driving lab. Now, forget your typical lab filled with robots and beakers. We're talking about AI-integrated continuous flow chemistry. Just try to picture this. A system where chemicals are constantly flowing through these tiny little reactors, and an AI is tweaking conditions like temperature and pressure millisecond by millisecond to get the absolute perfect reaction. And what this creates is this powerful autonomous loop. The AI suggests a recipe. The robot executes it. The results are instantly fed back to the AI, which then learns and refines the process for the next try. It's this continuous cycle of learning and improvement, and it's all happening without any human intervention. The secret sauce to this incredible efficiency is a strategy called Bayesian optimization. It's a fancy name, but the idea is pretty simple. While a human chemist might patiently change one variable at a time, the AI can juggle multiple variables at once. Temperature, pressure, solvent, you name it. Kind of like a master chef tweaking a super complex recipe. And this lets it find the perfect conditions for a reaction way, way faster. And the difference in efficiency is, it's just mind-blowing. As you can see here, an AI can get to a 95% yield in just 20 experiments. A human? They might still be stuck at 40% after 100 tries. We're talking about the difference between a single day's work for an AI and maybe 6 months of painstaking effort for a person. So, with all this incredible automation, it's totally natural to wonder, right? What's left for the human chemist to actually do? Are we about to be replaced by our own creations? This is the big question. It's on everyone's mind. Are we really watching the end of the organic chemist as we've known them? The answer is a resounding no. The chemist is absolutely not extinct, but their role is going through a radical transformation. The job description is basically being rewritten for this new era of human-AI collaboration.
And here's why the human chemist is still totally essential. There's this great saying that for all its power, AI is a powerful idiot. It's an incredibly powerful tool, for sure, but it lacks creativity, it lacks intuition, and frankly, it lacks the common sense that is the hallmark of human intelligence.
The AI can find the most efficient path, but it's the human who sets the destination. The human brings critical judgment, thinking about things like safety and intellectual property. And maybe most importantly, the human understands what's called the dark matter of chemistry, all the unwritten rules and hard-won experience that you just can't find in any database. So in this new world, the chemist's role is elevated. They're not just a technician at the bench anymore. They become the strategic leader, the project manager of this powerful team of AI and automation. They set the vision and guide the whole project. So what does all this mean for the future of chemistry? Well, it's a fundamental shift. We're moving away from celebrating individual genius and toward mastering the power of integrated systems. This quote from a recent industry analysis it hits the nail on the head. The challenge isn't just about having individual breakthroughs anymore. It's about building and integrating the systems that make those breakthroughs possible, reliable, and repeatable. And you can see the arc of progress right here. It's crystal clear. We've gone from chalkboards and beakers through the manual lab era, and now we are entering a new age of engineered chemical systems, where the power of AI and automation is just waiting to unlock a whole new wave of discovery. Look, this isn't the death of chemistry. It's a rebirth. It's a new frontier where human creativity and machine intelligence are going to combine to create a future we can only just begin to imagine. So the real question for all of us is, are we ready to embrace this new reality and become the architects of tomorrow?